Atomic History Jigsaw! Even as far back as 400 BC, the ancient Greeks started thinking about what the smallest piece of matter could be.
Ancient Greeks model philosopher Democritus believed all matter consists of extremely small particles that could not be divided. He called these particles atoms, from the Greek word atomos, means invincible.
Indivisible.
Indivisible.
All right, how long ago was that?
He made this discovery about 2,500 years ago.
Very good. All right.
Democritus and Aristotle and other Greek philosophers debated what atoms about 2,500 years ago. Aristotle did not think there was a limit to the number of times matter could be divided. Democritus believed that all matter consisted of extremely small particles that could not be divided.
Okay, and so in their time, what was everything divided into? Do you see what that word is?
It's fire, air,
Fire, air,
water.
and earth. So that's how everything was divided as opposed to the periodic table that we have now. That was 2,500 years ago. In 1803, John Dalton pictures atoms as tiny, indestructible particles with no internal structure.
That all matter is made up of individual particles called atoms which cannot be divided. Dalton, 1803, gathered evidence for the existence of atoms by measuring the masses that combined when common. Observations of behaviors of gases in the air. All elements are composed of an atom. Components contain atoms of more than one element. Dalton's pictures atoms as tiny, indestructible particles with no internal structure.
Perfect. Thank you.
Dalton's atomic theory. Full name, John Dalton. Date, 1766. Gathered evidence for the existent atoms by measuring the mass of elements that combined with compound form. Notice all the compounds have something in common. All elements are composed of atoms. Compounds contain atoms of more than one element. Over time, scientists found that all of Dalton's ideas about atoms were completely correct, but did not cause later scientists to discard.
In 1897, J.J. Thomson discovers the electron, leading to his plum pudding model. He pictures electrons embedded in a sphere of positive electric charge.
Model. The description in Thomson's experiment provided the first evidence that atoms are made of even smaller particles. In 1897, J.J. Thomson, he concluded that the particles in the beam had a negative charge because they were attracted to the positive plate. In the picture, the there's positive particles and negative particles, and you got waves going throughout it.
Perfect. Thank you.
Model of the atom. It's Thomson's model, and he called it the plum pudding model after like the English dessert. And he believed that the atom is neutral, meaning it has neither positive nor negative charge. In Thomson's model of the atom, the negative charges were evenly scattered throughout an atom filled with positive charged mass of matter. And no matter what metal he used for the disk, the particles produced were identical. The particles had about 1/2000 the mass of a hydrogen atom, the lightest atom. And then there's the picture up there, and it was in
Perfect.
1897, and his full name is Joseph John Thomson.
Very good. In 1911, Ernest Rutherford states that an atom has a dense, positively charged nucleus. Electrons move randomly in the space around the nucleus.
An atom has a dense, positively charged nucleus. Electrons move randomly in the space around the nucleus. Ernest Rutherford, 1911, the gold foil experiment. He aimed a narrow beam of alpha particles at the gold. thing around the gold was made of something else produced a flash of light when struck by a fast something alpha particle.
Okay, so here's their atomic model right here. Path of electrons around the nucleus.
Rutherford's model. Ernest Rutherford proposed his theory in 1909. And Rutherford discovered that uranium emits fast-moving particles that had a positive charge. He aimed a narrow beam of alpha particles at the gold screen around the gold. The screen around the gold was made of a material that produced a flash of light when struck with a fast-moving alpha particle.
So what did he propose in his model?
The nucleus is a dense positive charged mass located in the center of a atom. Is Rutherford's model in 1922. All of an atom, 90-degree positive charge, and that's our picture.
All right.
Nucleus. According to Rutherford's model, all of an atom's positive charge is what is it?
Concentrated?
It's in its nucleus. The nucleus is a dense positive charge mass located in the center of the atom. The alpha particles who pass were
Deflected.
by more than 90 degrees.
So what's in the nucleus right here?
Electron and proton.
Protons and neutrons. And then what are the minus signs outside of the nucleus?
Electron.
Electrons. All right, very good. In 1913, Niels Bohr proposes a model that electrons move in spherical orbits at a fixed distance from the nucleus.
This model description. Arrangement of electrons in an atom is the centerpiece of the modern atomic model. Evidence. Scientists can measure the energy gain with electrons, absorb energy, and move to a higher energy level. They can measure the energy released when the electrons return to a lower energy level.
Very good. So what's this part of the atom?
The center.
The center. What's the center called? Class, what's the center of the atom called? Nucleus. What's found in the nucleus at this point? What's the positive? What's the name of the positive particle? Proton. And then what are the negatives around the outside? Not neutrons, no. The negative are electrons. Very good. They're found in orbitals.
The description of the arrangement of electrons in the atom is the centerpiece of a modern atom. The date is 1913, and the dude's name is
Niels Bohr.
Niels Bohr. The electrons
Move.
in
Spherical.
orbit at fixed distances from the nucleus. An electron is an atom that can move from one energy level to another when the atom gains or loses energy.
All right, so the electron is the part of an atom that can move from one energy level to another. So it's on the exterior orbitals of the atom. So these electrons are in the orbitals. Very good. Thank you. 1926. Erwin Schrödinger develops mathematical equations to describe the motion of electrons in atoms. His work leads to the electron cloud model.
Electron cloud model. Erwin Schrödinger, 1887 through 1961. The cloud is denser at those locations where the probability of finding an electron is high. Electrons around the nucleus.
And they're in the electron cloud. And so they had the nucleus here with a cloud of electrons around it. Very good, Yadlin. Thank you.
Cloud model. Description. Electron cloud is a visual model location for electrons in an atom. The scientist and date is Erwin
Schrödinger.
1926. Evidence. Mathematical equations describe motion of the electrons.
Okay, so you have the nucleus here and then the cloud of electrons around it. Very good, thank you. In 1932, James Chadwick confirms the existence of neutrons, which have no charge. Atomic nuclei contain neutrons and positively charged protons.